Hey, hello guys, welcome back to my channel. It's really nice to have you guys here. So in today's video we are starting a new series, and the series is Arduino Adventures from Basic to Robotics. So from the name, so we want to start from the basics of robotics, like the electronics, then we can build on that to build robots using Arduino, and we're going to do all of that in this series. So but for today's class, or what we are looking at, is what are atoms. So we want to know atoms, and we want to know how our understanding of atoms can help us to build robots, right? So we want to go to the basics of physics and chemistry and understand atoms and build our experience on that to build robotics. So if you have never done physics or chemistry before in your life, so I think this will be much more fun for you, because this will be you learning physics and chemistry in a very simple way that you understand, and and it will still be very good. Okay, so I thought, like, for us to understand what atoms are, we should start with an experiment. So we want to have an experiment where we will create an atom by ourselves. That's going to be very cool, right? So the experiment is this. I want you guys to, like, the first step, I want you guys to take a piece of paper, like just like a piece of paper like this, like just cut it like a little bit, a bit like this. So then the second step, the second step is, I want you guys to cut that little paper into half. So now you have half of it. Then the next step, I want you guys to cut the paper into one half. Then this third step, I want you guys to keep cutting that paper into half. Keep cutting it into half. Keep cutting it into half. More half. I want you to do it like more half. More half. We want to create an atom. Then it will get to a point that you have a very tiny bit that you cannot cut no more. That tiny bit, right, is called an atom. Hopefully you guys can see this. It's called an atom, right? So atom of this paper is the tiniest part of this paper that we cannot destroy no more, right? So by definition then, atom is the smallest part of an element, or call it anything, right? Because like this paper is actually a compound in chemistry, but you don't need to worry yourself about that if you don't know what that is. But just assume that atom is the smallest part of anything. Like even if you take like a cloth or a wool, you keep cutting it into half, it will get to a point that you will not be able to cut it no more, right? That is what an atom is. So atom is the smallest part of an element that you cannot destroy. Okay, so if you have not done any physics or chemistry before, or you've not been to high school or college, right, this what I just explained, they'll probably teach you in college, right? So now you know it before you get to college. So remember, atom is the smallest part of an element you cannot destroy. So now how can we use that knowledge of this? Like, how does it relate to robotics? Okay, so just stay with me. It's going to be fun. All right, so we need to know some more things about atoms, right, before we can use it to have understanding on how to build robots, right? So that we'll have like a very good understanding on what we are trying to do here. So the first thing, just like history, it's good to know history, right? Like, it's good knowledge. So actually the word atom comes from an ancient Greek word called atomos, and this that I cannot pronounce, which means indivisible or uncuttable. So you see, it kind of makes sense, right? So like the word atom come from the Greek word. Like most of English words actually come from Greek word, right? So you can Google any word and say history of any word, you will see that they mostly come from the Greek word, right? Because like the Greek guys were the ones that were very educated during that time. Okay, so we can see atom means indivisible, uncuttable. All right, so let's come out of atom a little bit. Okay, so then matter. So matter is made of tiny particles called atoms. Okay, so now before we cut this, like this has like this is a matter. So matter by definition in physics is called anything that has mass or occupies space, anything that you can see. You yourself, by chemistry or physics definition, you are a matter, right? Matter is something, right? So this is a matter, right? So we are not saying that this matter is consist of atoms, right? Like lot of atoms, right? Because we broke it into smaller pieces, right? So we are saying that technically that this atom, this element consists of lot of these atoms, right? Kind of makes sense. Okay, good. All right, so now let's go. So matter consists of atoms. Okay, atoms combine to form compound. Example, water. So like the water that you guys see and you drink actually consists of two atoms, right? Which is hydrogen and oxygen. So we are trying to say here that atoms can combine together. Atoms from different elements, right, can combine together, because hydrogen, you know, is a separate element, oxygen is a separate element. So now atoms from those elements now come together to form water. Okay, so hopefully I've not lost you guys, but I'm going somewhere. Okay, so just for history too, this guy was the one that discovered atom, right, in this year 1766 and 1894. I think this year, like, I was in high school during that time. All right, so what's inside an atom? Now that we know the definition of atom and we are able to see that atom is very, very, very tiny. So what is inside that atom that help us to understand electronics, and will help us to understand robotics, and we even help us to build robots? Okay, so let's check it out. All right, so this is a structure of an atom. Again, of course, we can't see it with our eyes, but it's still in there. Okay, this is the structure of an atom. So you guys don't have to memorize this, but if you want to memorize it, it's cool, because if you are doing sciences if you're not in high school or college yet and you are doing sciences at that level, you 100% have to know this. Okay, so structure of an atom. Okay, so the atom has proton, which is positive charge, as is inside a nucleus. So like this is the nucleus, right, of the atom, of course, which we cannot see, but if you put it under a very powerful microscope, this is what you will get. So you have a proton, which is positive charge. You just have to know that. Okay, then we have neutron, which is negative, like neutral, like no charge, right? So this is proton, this is neutron, and they are all inside the nucleus. And we have electron, which is outside the nucleus. You can see right there, and it's negative charge. Okay, so electron is the most important of an atom. Okay, so what we are focusing on here is going to be electrons, because electrons is actually the one that gives us current, and the current is what that powers our light and phone and everything. So technically these electrons are the one that power our devices, right, that power our robot and all of that. So that's why I want us to go to that level to understand what electrons are. And for us to talk about electrons, we have to talk about atom, of course. All right, so just for you to guys to have a visual representation of this, think of a nucleus as a candy ball. Okay, most of you guys like candy, and electrons as bees buzzing around it, right? So you have a candy ball, then bees are going around this, so bees are the electrons. That is how you can visually represent it, even though you cannot see what is inside this atom. Okay, all right, good. So now let's focus our attention on electrons, because that is what we really need to understand. So electrons, like I said, are the one that gives us current, that power our phones, our TV, our laptop, everything, like your refrigerator, everything that you see, like even your lamp. Electrons are the one that actually powers it, right? So we want to understand how electron does that, like do that rather. So it also power robotics and all electronic devices. So now let's try to understand how that works. Okay, so the question is, how does electrons give current? All right, so please, you guys, please listen very well, because if you get this now, it will stay with you forever. Okay, it's very, very cool and very, very interesting how things work. Okay, imagine copper wire. So like this is a copper wire, right? Just this one copper wire, right? And remember that I said that anything like this copper wire is a matter. Like matter is anything that you can see around, right? Anything. And matters have electrons. So that means all of this like wire has atoms. Atoms are the tiny parts. So like just imagine how many atoms that we're going to have in this wire. Very, very tiny, like compact together. So we have a lot of atoms in this wire, and each of those atoms we have electrons, right? So that means we have tons of electrons in this wire only. All right, so that's why I said that copper have electrons in them. Okay, copper wire has atoms, okay, and atoms have electrons, right? Just like we said that this paper also have atoms, right? And this paper atoms has electrons. So this paper actually has electrons too. All right, cool. So electrons in copper wires move freely inside of them, right? This electron, they move freely around the copper wire. I'll still give you guys like a visual of them moving around. Okay, very, very cool diagram. So, and when electrons flows out of the wire, it gives current. Yeah, this is where the magic happens. So as the electron move around this wire, like they don't move out, of course, but if they flow out of the wire and flow into your phone or into your lamp or into anything, they will give current, right? That is how electrons give current. Again, I will give you guys a visual representation of that. So the next question is, how can we make electrons to flow out of the wire to give current to our device? That's the next question, right? Because we say that by default electrons move inside these wires, but they don't move out by default. No, like electron in this paper don't move out. Electron in this wire, because like that's wire inside of this, the electrons don't move out, right? So now how do we move the electrons out to give us current? So let's look at that. So okay, so this diagram is actually for this one. So you can see like this, like inside of a copper wire, we can see that the electrons are moving around it inside, but they are not moving out, right? So one thing you should see, so unless they move out, that's when they will give current to power our devices, right? So they are moving inside, but how can we make them to move out of the wire so that they can power our devices? So how do we move electrons? We use batteries to move electrons, right? So because sometimes when you plug your charger, like your devices or your remote or your robot car or anything to battery, you think that the battery is the one powering your device. No, the battery is the one that pumps the electron out of the wire to move around and power your device. The current is not coming from the battery. The current is coming from the electrons in your wire. Okay, please don't forget that. Very interesting, right? So like I said, battery don't give current. No, your battery does not give you current, right? Battery give power for the electrons to move, and when the electron moves, then they give you current. You can see the electrons are moving because we like this battery is the one that pump the, okay, so one more details, right? So we have positive terminal and negative terminal on the battery, right? Okay, all right guys, so this is actually the negative side of the battery and this is the positive, right? For this kind of battery, the big side is the negative, right? This is wrong, right? So that means the electron is negative, right? So the negative electron is being pulled or attracted to the positive side. So you can see the electron flows and they are attracted to the positive side of the battery, right? So that is how the battery is able to pull the electron, right? And the more powerful your battery is, the more electrons that you get, right? The more electron that is able to pull out of the wire, right? And if the battery is much more powerful than the wire, then the wire, like the battery, will pull more electrons than the wire can supply. Then that's why you see that some wire will burn out, because the battery has more power than the wire, right? So you must make sure that the wire that you want to connect has enough electrons kind of that the battery will require. So that's for that. So the moving of electrons gives us current. The battery does not really power your device. The battery pulls the electron from the wire. So without the wire, you cannot power your device, right? So essentially when you have your charger, right, the electrons in the wire of your charger is the one that actually power your phones and charge your phones. Okay, so another point, knowing this will help us to better know how to program robots, right? So because when we have robots, we want the robot to move or not to move, right? So we can use program code to say current should flow, current should not flow, electron should flow, electron should not flow. Okay, makes sense? All right, so yeah, this is just like an example, right? So you can see this is the wire, you know, then the electron is flowing. Then if you connect that to like a LED or bulb or anything, then this will come up. Okay, so if you have an open circuit in here, meaning that this is not connected, so that means as the electron is flowing, the electron is not flowing to this guy, then this will not come on. All right, by the way, I got this cool animation from this website, engineeringmindset.com, so you can check it out. Okay, so since everything has atoms, okay, everything has atoms, you yourself, you have atoms, right? And atoms have electrons. Why can't this supposed to be can't? Why can't everything like connected to battery give current, right? If you connect like a wool or a thread to your battery, it will, like, that has electrons, right? But it will power up anything. So why is it that copper wire is able to power something and thread is not able to power something? So let's answer that question. All right, so this is a very cool diagram of the copper atom, right? You can see these are the like the nucleus, the proton and the neutron, right? So we really don't care about that, but these are the electrons. So copper has 29 electrons in its atom, right? That's chemistry. If you want to know that, you can dig deep, right? So but the electrons are arranged in a way that copper has one electron outside the shell. See, this is the shell. You can see it has one electron outside here, right? So so the electron is easy to be moved by battery because this electron is just the only one here. So the battery can easily move it out from the atom, right? So the battery, it's easy for the battery to pump it. As you can see, like this is the copper atom, right? And you can see is that one electron outside that is moving, just that one, right? And that one is moving because it's the only one there. So other metals like iron, aluminum, that can also conduct electricity, they also have like one, or I think aluminum has 2 and iron has 2, or aluminum 3. Yeah, I don't know, you have to confirm that. Yeah, it's been a while I did chemistry, right? But they have few electrons, so the copper, like the battery is able to move them around, okay? But things like plastic, rubber, paper, they have electrons in their outer shell that is difficult to move. Like maybe they have like 5 or 6 at the outer shell, so the battery is not able to move them, right? Because there are many, right? So that is why some materials like plastic or rubber or paper, they are not able to conduct electricity, right? They still have atoms, they still have electrons, but they cannot conduct electricity because the electrons at the outer shell here, you know, is too much for the battery to pump, to move. Let's say it that way. All right, so atoms like copper, they are called conductors, right? Atoms that have few electrons outside the air that can conduct electricity, they are called conductors. And atoms like plastic, wool, paper, they are called insulators. Okay, yeah, you should know that actually, you know, conductors and insulators. So conductors can conduct electricity. Insulator, they cannot conduct electricity, they insulate, right? So all right, so at least you guys have understanding of this, because we're going to build on this, right, to kind of work on our robot. Okay, so but just one more interesting thing that I want to you guys to understand. Okay, so the question, why do you get zapped, like static, in winter when you touch doorknobs? Okay, so let's use our knowledge of atom to kind of explain that now. Okay, cool. All right, so when you rub your hand on your clothes, electrons flow from your clothes to your hand. That happens. So in winter, when, like in any season actually, when you rub your hand on your clothes, electrons actually move from your clothes to your hand, right? So then in summer and spring, these electrons do not cause anything because there is water molecules in the air. So in summer and spring, when you touch your clothes and you have electron on your palm, there's the air around you is not dry, so the water in the air will dampen the electrons, so nothing will happen if you touch like a doorknob, right? But in winter, in your house, you have heater, right? So the heater will dry out the water in the air, so that means there is no water to dampen the effect of the electron on your palm. So when you touch a door handle or just friction from walking, the electron that you got from your clothes that is on your palm will flow to the door, and because the door handle is metal, right, so the electron will flow from your hand to the door handle, electron then causing a spark, and that is what gives you static. All right, so if you don't want this to happen, you can always rub like a lotion on your hand and you'll be good. Okay, something interesting for you guys to learn about. So another thing that I want to teach you guys, just a little bit of mathematics, right? How to calculate current in a wire. So if we say that current is generated when electron moves, right? So we all know that. So when we have your battery, the battery pulls electron from the wire, and because the electron are moving, by the way, when the electron move this way, current will move the opposite way. And the details of that is electric field is advanced physics, right? So I don't want to bore you guys, but let's just do some little calculations. So current is how fast electron is moving, right? So that means if this battery is more powerful and it is moving electron at a very fast rate, then we have more current, right? So that means current is the number of electrons moving at a particular point divided by time, like the rate of flow of electron, how fast the electron is moving is what current is. So now when you have a large battery, it pulls more electrons and you have more current. I explained that. So now just a question, what is the current in a circuit if you have 100 electrons passing a point in 5 seconds, right? So that means the current will be 100, so 100 electron divided by the time that they pass, and it's going to be 20, and the unit for current is amp, right? So like this is high school physics actually, okay? So for the student in my class, right, I will give you guys an example like this, so you should know how to calculate current from electron and time. Okay, sounds good. All right, so this is the end of the first lecture. Hopefully you guys enjoyed it. So what we are doing next is actually installing all the application that we're going to use for developing our robots, right? So our application for Arduino. Then we are going to also explore the components that we have in our kit, right? So again, well, if you have, so like we are using this Lego R3 kit for this class. I'll put the Amazon link in the description so that you can get yours. So we want to build robots, from all these devices, like this component, right? And I think that you guys will really love it. So next class we'll install all the applications on our laptop, like just one application actually. Then I will introduce you guys to each of the components, like what they are all doing, and how we are going to use them, and how they are actually using some of these components in application that we have, right, in our environment. Like this one now, this is a sonar sensor. It's the kind of sensor that is in your car that assists people to park, like for advanced cars, right? Something like this. Like then this is like a joystick that you can use to control, like that you use to control game and all of that. Like this is like a smoke detector, I think, smoke detector, and a lot of cool stuff. So I will introduce it to you guys next week, and we'll start from there. Okay, and please don't forget to like, please subscribe and share with your friend. Thank you so much for watching this video. I will see you guys in the next class. Bye.